From the last video, we have discussed the read uncommitted and read committed. Let's continue to explore repeatable read and serializable in this video. This is a definition of repeatable read from MySql document. This is a default isolation level for InnoDB. Consistent reads within the same transaction read the snapshot established by the first read. This means that if you issue several plain non-locking select statements within the same transaction, these select statements are consistent also with respect to each other. Let me explain a little bit more here. In repeatable read, if we have multiple select statements in one transaction, MySql InnoDB engine only reading a snapshot was created by the first select. No matter how many other concurrent transactions changes the same data, those updates are not visible to the subsequent select statements. What is the issue from repeatable read in MySql? That is a phantom read. However, try to reproduce phantom read is a little bit different in MySql, but there is still a way that you can see it. Let's jump into the example. We will continue to use the balance table from the last video. T1 first reads the balance table. Then, T2 inserts a new record with user ID 2 and commits a change. Then T1 tries to update the record which is inserted by T2 and then reads the whole table again. Do you think transaction 1 can see the newly inserted record by transaction 2 during its execution? Let's run and see how MySql behaves. As you can see, transaction 1 reads one record at the first time and reads two records at the second time. We just created a phantom read in MySql. MySql mentioned this behavior in their document. If a transaction does update or delete rows committed by a different transaction, those changes do become visible to the current transaction. You can read more if you are interested. How can we address the phantom read? That is serializable. Serializable is the highest isolation level in MySql. By definition, serializable isolation guarantees that even though transactions may execute in parallel, the result is the same as if they had executed one at a time, without any concurrency. Let's go back to the editor and update the SQL to use serializable. As you can see, the transaction 2 is waiting on transaction 1's execution. After T1 finish, T2 inserts a record. We can see the two different reads in T1 are consistent now. Serializable isolation assigns lock to the select statements, so that no other concurrent transactions can update the selected rows. I will cover more about MySql logs in the next video. Quote an example from Design Data-Intensive Applications book. Imagine we design an on-call system for a hospital. We need to make sure at least one doctor is on call. Alice and Bob are on call, but they both are not feeling well and want to log off. They click the button at the same time. In each transaction, the select statements return 2 for current on-call counts and allow both updates to happen. Now the system has 0 doctor on call and causing the issue. In this case, we need to use serializable isolation level to ensure that no other transactions can make changes while the current transaction is running. As your application scales and the number of concurrent users grows, handling simultaneous transactions becomes inevitable. To ensure optimal performance and prevent potential issues, it is crucial to understand your application behavior and choose the appropriate isolation level. By doing so, you can strike the right balance between consistency and efficiency. I hope you have learned something here. Thank you.